Good evening, everyone. Welcome back to our session. So today we are going to start a new playlist on recurrent neural network. Okay, so as we have done sessions on ANN, CNN, in the same way we have planned, a series of sessions for RNN as well, recurrent neural network. So as part of this playlist, we are going to understand what are recurrent neural networks, how are they trained. Then the model architecture, we are going to understand the architecture of RNN, recurrent neural networks, followed by, at the end of this particular sessions, we are going to implement RNN on a data set. Okay, so we are going to plan a use case on RNN as well. Right. So before we start the topic, I'll quickly show you my YouTube channel. So friends, this is our YouTube channel. Okay, next there are Unitech. Consider subscribing because we are going to plan, we are going to come up with, you know, n number of upcoming programs we have in the playlist. Okay, so we have done a playlist for NLP, ANN, CNN. Then we also have a playlist for regression, classification, then Power BI, SQL, and Python. Right? So do subscribe our YouTube channel. So if you had any kind of questions, also post your doubts, your questions to that respective video that you have watched. We'll respond to your questions immediately. Right. So do also share across your connections, ask them to learn all the important topics that are available on our channel. Right. So before we start, RNN, recurrent neural networks, we'll quickly recap ANN, CNN, because until unless if you are aware of ANN, the basic neural networks, you cannot understand RNN, right? But anyhow, we'll recap ANN and CNN initially, then we'll understand what is sequential data, because sequential data is used, RNN uses sequential data to process. So why not ANN and CNN is also being addressed. Okay, what exactly sequential data we'll understand. Then in today's session, we'll get introduced to RNNs. Then probably in the next session, we'll talk about the architecture, okay, the working principle and all. Making sense? Yes. So without no further delay, let's get started and we'll quickly recap ANN and CNN. So ANN, the full form of ANN is artificial neural network and CNN is convolutional neural network. If you take ANN, so, ANN, what is the purpose of using ANN, friends? Why should we use ANN? ANN helps us to, mimic. The neural networks are inspired based on the human brain. Okay. And all these layers that we have inside neural network are interconnected. Okay. Based on the neurons. And these help us to process the information. And within an ANN, you'll have three main layers: input layer, hidden layer, and output layer. So input layer receives the input data, and within the hidden layers, we are going to perform the computations, right? And this hidden layer helps us to also extract the features present in the, input the data, and the output layer produces the result. So in final, you're going to get the prediction from the output layer. All right. So we understood how we are able to classify, and we are also able to predict continuous data as part of ANN. So traditional neural networks, we can go and use it for the classification and regression task. right? Depending on the activation function that you're going to use, it depends on the task. Then, but the question comes is how ANNs work. ANNs completely they work on the neural networks, they work on, the weighted sum of inputs. So within a neuron of hidden layer and output layer neurons, you have two parts. One is summation function and activation function. So summation function is uh, actually going to get the weighted sum. Okay, it is responsible to calculate the weighted sum of inputs. Then activation function is an mathematical function which helps us to, get the output, right? So we generally use sigmoid, ReLU, TANH, ELU, leaky ReLU, softmax, and all. So across the journey of ANN, we keep on updating weights and bias, okay, to minimize the loss. The objective of ANN is to minimize the loss function. So this loss function, the cost function, okay, uh, in order to get reduced, we backpropagate and, I have discussed ANN clearly as part of the playlist. So friends, if you are new to the channel, just go and watch ANN session. Okay, a complete playlist is available for ANN. Do watch the ANN, artificial neural network. Then coming to the applications of ANN, we have performed a classification task, but ANN can also be used for regression tasks, for general purpose machine learning tasks as well. Yes. But the limitations that ANN has is it does not treat, it treats all the inputs as independent. Whatever the inputs that you have, X1, X2, and so on, all of them will be treated independent. And this is ANN is not going to keep any memory of the past data. Okay. So no memory will be stored with respect to the inputs. And it is not suitable for sequential data or spatial data. Okay, if you have images, okay, videos. So we understood why ANNs is not suitable for sequential and spatial data. We have understood, right? Yes. Then coming to CNNs, CNNs are, the full form of CNNs is convolutional neural networks. They are especially designed, they are, specialized type of neural networks. They are designed for spatial data, that is images. So if you are going to work on images, videos, data, then obviously CNNs are preferred. Okay, so when it comes to the key components, so friends, this is my ongoing playlist. I'm parallelly explaining CNN as well in the 4-minute session. Do join the sessions of CNN to understand convolutional neural networks to the depth, right? Yes. So let me explain what is the key. What are the key components of CNN? We have convolutional layers. We also have pooling layers. Then finally, fully connected layers. So in the convolutional layer, we apply filters, the kernels on the input data, to detect the uh, patterns. So whatever the hidden patterns, the edges, the textures will be detected using filters. So in convolutional layer, the convolution operation occurs, and this is going to reduce the number of parameters. Right. So instead of directly having a fully connected layer, it's better if you go and have a convolutional layer initially, the number of features gets reduced. Right. Next to convolution layer, we'll have a pooling layer, and this pooling layer is going to downsample the features still. Okay, we are going to uh, get the samples, the features we get reduced. Okay, so that the dimensionality of the inputs get reduced if you apply a pooling layer. Okay, so general pooling layer techniques will have it as max pooling, average pooling, then global pooling, min pooling, and all. Right. So friends, if you are not aware of all these particular topics, go and watch CNN playlist. Okay, detailed playlist is available in our YouTube channel. Do and go and watch our sessions on CNN, convolutional neural networks. So how CNNs work is initially the filters get performs convolution operation on the input layer, on the input data to detect the patterns, the edges, and the textures. Then we also come up with pooling layers, to reduce the dimensionality. And finally, we have fully connected layers, and these fully connected layers are used to interpret the features. The features that you get from the pooling layer will be interpreted, and it produces the outputs. So this is the working principle of, CNN. Now, if you ask me the applications, yes, anything related to images, friends. So you take image classification, image segmentation, object detection, yes. Okay, so all these are some of the applications that CNN works well. Okay, if the data that you're working on is unstructured data and it is especially text, sorry, if it is videos, images, yes, go and use CNNs. Then what are the limitations that you observe in CNNs? Are CNNs, they are built only for, spatial data, that is images. What about sequential data? Akhil, from time again, we are using the word sequential data. What exactly is sequential data? We'll understand, friends, no issues. So CNNs are not built for sequential data. They don't work well for sequential data. Okay, so let us understand what exactly is this sequential data initial. Okay, since ANNs and CNNs are designed for a different data, not for sequential data. Okay, that's where RNNs came into the picture. RNN stands for Recurrent Neural Networks. So friends, do you have any idea about what is the general meaning of recurrent? What is the English meaning for recurrent? Recurrent. What do you mean by recurrent in English? Excuse me. So you see reoccurrence, which is nothing but, occurring repeatedly. Okay. So when we are discussing the architecture of RNN, I'll be explaining why RNN is named with recurrent neural network. It's a type of neural network, where it occurs repeatedly. What is going to occur? Okay, so that part we are going to discuss as part of architecture, the working principle, right? So probably, yes. So ANNs and CNNs, they are not designed for sequential data. When it comes to sequential data, what exactly is sequential data? The data which has a sequence is nothing but sequential data. Example text, time series data. If you take a time series data, is time series data sequential data? Yes. The order of the data that we are going to record will be present in a sequence of time. Okay, so if you take any physical store, let me take Walmart. So if you take Walmart, so number of footfalls, I want to predict number of footfalls into Walmart. Okay, so what is the time column that I'm going to take is day-wise data. So on each and every day, okay, on this particular date, what is the number of footfalls we are supposed to forecast? So we are going to use time series data, which is a sequential data. Again, if you take text, each and every word in a sentence or in a paragraph, okay, or even as part of a story, whatever it might be, each and every word will be dependent on the previous words. So within a line, within a sentence, the next word within a sentence will be decided, that is dependent on the previous words or not. Yes. So that is where the sequence matters. So such kind of data is called sequential data. And what is making RNNs different? Apart from CNNs and ANNs, what is the unique feature that RNN has is RNN is going to have a memory. Okay, which is useful to store the information about the previous inputs. So whatever the inputs that you're going to pass in CNNs and ANNs, there is no component called memory, and this memory is available in RNNs, recurrent neural network, and they are responsible for storing the information of the inputs. So when you pass the inputs from the input layer, what happens? So in general, if it is ANN or CNN, there is no component called memory, and it is not going to store any kind of information about the past data. But in RNNs, there is memory. Okay, how is this memory going to help RNN? We'll understand. So I have a comparison table, okay, between ANN, CNN, and RNN, because if you go through this table, probably, we can understand the differences between now the neural networks well. So with respect to input type, ANNs take structured data. It might be cross-sectional data or panel data, right? You go and use any structured data. Yes, ANNs work well for structured data, but if you are working on images, what if you want to work on image data, videos, then CNNs comes into the picture, friends. Okay, what about RNNs? RNNs work for sequential data, example text. Okay, example text. If not, we also have, you know, time series data, right? So all these come under sequential data. Then do we have memory as a feature in these networks? In ANN, no memory. In CNN also, there is no memory, but RNNs, yes. They have a memory component which is helping RNNs to store the past inputs. Okay, whatever the previous inputs that we are passing as part of training journey, is RNN is going to store all the information regarding the inputs. Then, what are the key layers with respect to the neural networks? Is obviously a fully connected layer. So each and every layer present in ANN will have it as a fully connected layer. Dense layer is what we observe. But when it comes to CNNs, the key layers are convolutional layer and the pooling layer. Okay, the main operation in CNNs happen in convolution and pooling layers only. Okay, in the convolution layer, the convolution operation happens, and the pooling layer, it is going to reduce the dimensionality. Once after the pooling layer is done, then we'll have again the fully connected layer where we can get the output at the end, the prediction. Then in RNNs, we'll have recurrent layers. Okay, so what are these recurrent layers? You'll understand, friends. Okay, when it comes to the applications, ANNs are generally used for classification tasks and regression tasks. Okay, but for CNNs, we use for image processing. Okay, since they work on image related data. Okay, we use CNNs for image classification, image segmentation, object detection, and all. Yes. Then RNNs, the applications are NLP, natural language processing, time series. So if you want to forecast the data, forecasting weather, okay, forecasting temperature, forecasting humidity. So all these come under, time series data. So these are some of the applications where RNNs are widely used. So making sense? A quick introduction about the comparison of ANN, CNN, and RNN is what we have understood. And now let us get understood. We'll get introduced to RNN, friends. Okay, before that, I should explain what is sequential data, right? Yes. So sequential data. I have no questions so far. Yep. Right. So let us discuss. What exactly is sequential data? Sequential data is a type of data where the order of the element matters. So something that you have to identify is order. The sequence, the order matters in sequence data. Each and every element in the sequential data is related to the previous and or next elements. So whatever the data that you are going to have as part of sequential data, the sequence is matters. What are the examples of sequential data? Time series data. So stock market, you take stock market. So how many of you invest in stock market? Many of us, right? If you have knowledge on stocks, obviously shares, we go and invest. But do you know that you are indirectly, without noticing yourself, you're working on time series data. And if you learn RNN, if you learn recurrent neural networks, why don't you build a model that is going to forecast your stock value? Yes, even this is also possible, friends. A lot of experts, they do this way. Okay, so stock prices over time. How do the stock prices change? Are the stock prices constant across the time period? No, they change. So this is one of the example that I'm very interested to talk about. The main reason is, nowadays everyone is running behind money, right? So stocks is a place where we gain money as well as we also lose money. So if you have knowledge and if you're going to play stocks accordingly, yes, obviously the returns somehow, even though if you don't gain more in a single day, obviously you'll be receiving a good amount in some other day. But what if you don't have any knowledge and just for namesake you're investing? Then obviously you'll see the downfall, right? So stock prices over time, which is a time series data, okay, is a sequential data on which RNN can be built. Okay, I can use RNN to build a model for predicting stocks. Then weather data, that's what we have discussed. Predicting, forecasting temperature, forecasting humidity, okay, forecasting something else, forecasting whether it will rain tomorrow or not, okay, forecasting the amount of earthquake. So all these come under, time series data only, friends. Sensor data. So whenever you monitor your heart rate, okay, across the time, the sensor is going to provide the data, right? So all these fall under, you know, time series data. Apart from time series data, we have text data. So if you take text data is the best example for sequential data. Okay, each and every word present in a sentence, okay, they have a meaning only if they are in a specific order. Okay, so if there is a sentence like this, what if the words are jumbled here and there? Will they have a meaning? No. Until unless if the words are arranged in a specific order, only then that words will, frame a sentence and the particular sentence will have a meaning. So text data is one of the best example for sequential data. In the same way, code. Okay, you take any programming language, yeah, whenever you are using a programming language to define your script code, so it also comes as a sequence, one after the other. Then audio data, so in which you have music and speech. Yes, so you take audio data, within an audio, you'll have music. Even music is also, broken as words which have a proper specific order. So audio data is again considered as a sequential data. So these are the examples of sequential data, we also take video. Again, when video is made into frames, so obviously RNNs work, but they don't give you the good, score. The output may not be good. Probably you can use RNN to build the model, to train your model, but the output may not be good. So these are some of the examples of sequential data. Then coming to the next topic, let us go and understand how this, why traditional neural networks struggle to work on sequential data. If you take ANN, probably there is no memory inside it, right? So when you take ANN, let me take a classification problem. So each and every input will be passed to the input layer neurons. I'll be passing the inputs. Yes. So I'm just taking a classification problem, friends. So if you take a classification problem, whether to predict male is spam or ham. Okay. So you'll pass some input values to these input layer neurons. Yes. So what if I change the values here and there? My output still be same? Yes. So for example, if I pass x1, x2, x3 in this way, there are three inputs, I assume. Okay, I'll get one output. Yes. Instead of passing x1 here, I'll pass x1 to the third neuron. x3 I'll pass to the second neuron. x2 I'll pass to the first neuron. Will I get the same output? Yes, obviously. So what can you infer from this particular example is, even though if you change the order for your inputs, the output is not affecting. But if you take a text data, if you take a text data in which you have words, sequential data, right? Text data is nothing but sequential data. Assume I have took a sentence. I love NLP is a sentence. So I have to pass the inputs by breaking this sentence to as tokens. I'll pass I here, love here, NLP to the third neuron. Probably, the order is okay. The sequence is matching. Fine. What if I change the sequence? Will the output be same again? No. So that is where, our sequence or the order of the data is, it is very important with respect to sequential data. And RNN, why traditional ANNs cannot be used on sequential data is, this is one reason. And moreover, they don't have any memory, so that they don't remember the past inputs, the value that we pass for the past inputs. Making sense? Yes. And why does RNNs are suitable for sequential data? RNNs help us to remember. There is a component called memory, and this is going to remember the past inputs. Okay, and moreover, it is capable of processing sequential data in a great way, and it can also handle variable length sequences. Even though if you have different sequences, each and every text, if you take a sentence, within first sentence, I may have only 5 words, but in second sentence, I may have 10 words. So even though if the number of inputs change with respect to sentence, even the variable length sequences can be handled by RNNs. Okay, but when it comes to ANN and CNN, they fail. I hope it's making sense. So now let us understand, let us just get introduced to RNN, then probably I'll stop the session, right? So if you see here, RNNs, they don't have a different The architecture is completely different. You see, so within each and every layer, we have neurons. Yes, I'll go back. So they are type of neural networks defined, they are designed to handle sequential data, and they have a memory that captures the information about previous inputs in the sequence. Okay. And RNNs, they process inputs all the at a time. Okay. Updating their hidden state at each step. So at each and every step, they are going to update the hidden state. What is the hidden state? We'll understand. This particular hidden state is going to act as a memory, which is going to store the information of the previous inputs. So whatever the inputs that we have will be, yes, stored as part of, the hidden state. Just give me a minute. Oof. Right. And if you see the key features of RNNs, will have memory, shared parameters, and the flexibility. These are the key features. So within the memory feature, we have the hidden state, which is going to capture the information about the past inputs and the shared parameters. The weights will be shared across all the steps. In return, it is going to reduce the number of parameters. If you take ANN or CNN, the weights keep on, changing, right? The number of parameters will be keeping on changing. But if you take an RNN, the RNN weights will be keep on, they'll be using the same weights across different steps as well. Okay, so that is one particular feature of RNN. So why it is using the same weights and all, we'll understand, friends, no issues. Then when it comes to flexibility, yes, it can handle sequence of varying length data as well. That's what we have discussed. So if you take different sequential data text, yes, even though if the length may change, but still, you see, it can handle various varying length data as well. So this is just an introduction part to RNN, and in the coming session, we'll be discussing the architecture to RNN. Okay, so we'll be discussing how RNN works. Okay, then we'll also discuss the mathematical representations. What is this? We have many new parameters coming in the picture. Okay, what is the word called recurrent? We'll understand. Then the back propagation. Then the types of RNN. This is very important. Okay, one to one, one to many to one, and many to many. Okay, so we'll discuss all the important types of RNN. Then the variants of RNN. Okay, so this particular session, we just understood what is RNN, what is sequential data. Okay, so we have quickly revised all the basics, and we also understood why ANNs and CNNs are unable to fit for sequential data, right? So in the upcoming session, probably we'll understand how RNNs work. Okay, and yes, we'll understand the architecture of RNN as well, the types. Right, I'll stop the session here. If you have any kind of questions, yes, feel free to share your questions. Okay. So assuming no questions, friends, just go through the previous sessions as well, because these are like continuation topics. If you are directly jumping into these advanced topics, you may not grab the session properly. The topics may not be clear. So just go through the previous sessions as well. Then, you know, come and learn these particular topics. So that's all for the day. Again, we'll meet in the next session. Until then, take care. Have a great day. Signing off. Bye.